Good morning, everyone. We are just going to start today's session shortly. All right. So I have already provisioned the Jenkins machine. We are going to use the same machine in which we used in our last session. Okay. So let me just connect to this machine, and then we are going to start. All right. So our Jenkins master and build Maven. Okay. That is our Jenkins slave server. Okay. Both the servers are up and running. Let's verify if the Jenkins is up and running. So Jenkins is also up and running. All right, so Jenkins is starting now, and we already created a Maven job. We were in the process of creating a Maven job. Okay, so let the Jenkins comes up, and we are going to complete that uh, example that we were completing the last week. Okay, so anyone having any doubts in the meantime, you can ask now. All right, there we go. So we can log in to our Jenkins. So I'm going to use my. So Jenkins has just loaded. Uh, okay, so we are inside the Jenkins now, and let's go inside our production environment where we created the job. Inside production, we created a cart folder, and here we have created dev code review and dev compile. Okay, so these were the two jobs that we created last time. Okay, and the code review generates the review of the code using the PMD, where it shows the warnings which are associated with the code. Okay, the after the code review comes your QA unit test. Okay, that is the unit test cases that are being executed. Okay, so let's go ahead and create a new job. Okay, so we are going to go to the new item, and this time we are going to generate a job that is QA unit test. QA unit test. Okay, and we are going to copy the code, that is the repository and everything, save as def compile. Okay, now only thing which is going to change here is the Maven goal. Okay, so let's go to the QA unit test job. So the goal for this job will be to run the test. Okay. All right. So we are inside the QA unit test, and here is our repository, Git repository, which we were using, and we will have to change the goal here. So the goal for QA unit test will be the test. The test is going to execute all the unit test cases which have been written for the QA unit test job. And let's click on save, and we can go ahead and execute this job now. Okay, so we are going to run the unit test cases. All right, by the time this runs, let's create a new job. Okay, so we are again going to go inside the cart. After the unit test cases have been executed, we need to run the code coverage. The code coverage shows us how much code is being covered by the unit test cases that have been written. Okay, so for generating the code coverage, okay, the next job that we are going to create is code coverage. Okay, and we are again going to copy that from dev compile itself. Do okay. Now we are going to go inside the plugins, and we are going to install a new plugin. This time, the code coverage for Java is Covertura. Okay, so each of the application have their own code coverage tools which you can use, and those are available in the form of plugins as well. So we are going to install the Covertura. Covertura is basically the code coverage tool for Java based application. Okay, so let this load. We can go here and look out for the execution. What's happening here? Okay, under the available plugins, let's search out for the Covertura. Okay, here is the test cases are being getting executed. So here is the results. If you will see, these are the details of the tests that are being run. Okay, so 14 test cases have been executed and 0 resulted in failure. Okay, so 0 tests were failed. So this is and how you can run the test cases, unit test cases. Okay, let's go back to the plugins and let's search for Covertura. So here is the Covertura plugin. just select it and click on install without restart. All right, let's go inside our job and we are going to change the goal to covertura okay. So this is the goal for our code coverage that we are going to run. Okay, let's just save this and let's run this. Now we are going to create our final job. That is, we are going to generate the artifact. What is artifact? Artifact is basically the main package which you wanted to generate. And in our case, it will be a address book.var file. So we can generate a package. We can create a new job called QA package. Okay. And we are going to copy this from def compile. Okay. All right. So under this, we are going to change the name goal for the Maven to be package because we are generating the package. Okay. And we can click on apply and save. Okay. Now, if we trigger the build for the QA package, the package is going to be generated. This is the code coverage which is running. Okay. Right now, Jenkins is executing the code coverage. Once the code coverage gets finished, then the package job will start to execute. So here it is, 23 test cases have been executed and coverture report generation was successful, and at the same time all the test cases were passed. Okay, that was for the code coverage part. Now if we come down to the QA package, it's still getting executed. So the goal will be described to you by the developer. Okay, so the developer who is responsible for the project, they are going to provide you the Maven goal. Okay, you this is basically a way of how you are going to code and how you are going to compile your code that is defined in the goal. Since the developers are writing that code, so they are going to define the goal, and you can obviously get in sync with them and tell them that we can discuss them regarding the code review, you executing unit test cases and so. Okay, and they are the ones who are going to code it. Okay, now let's go to the QA package job. This has completed executed execution. So if you will see here, let's go down, and here you will see this war file has been generated. Okay, this is the artifact we are talking about. You can simply copy this artifact onto the remote server using the shell script and deploy it. Now let's say if you are having sorry, not this server, the slave server. Okay, now if you are having comparatively larger number of servers on which this job needs to be copied, and large number of steps like Tomcat needs to be restarted, permission needs to change and so on, you can either use scripting if you like. Any of the scripts can do it, bash, python and so on. Otherwise you can use the Ansible or Puppet that we have covered, or Chef and Salt. Any of the four you can use uh, over here. They are automatically going to copy this address book.war as you write in the task file, and going to run the steps and going to deploy on all the servers that you are having. Okay, so no, they don't need to be proficient with the Jenkins. Okay, they will only tell you that these are the goals which needs to be executed for Maven. Okay, Jenkins, Maven can execute without Jenkins as well. Okay, Jenkins is there for automation only. Okay, if it's like that you install the Maven locally, and whatever command that we are firing through Jenkins, we can do it through directly over the command line. Okay, but then there are large number of things to be done. Okay, so many test cases to be executed, so many stages are there. So you will have to continuously stop working on other things, and you will have to focus on the server side. Then you are not having the recording of what was executed when the last build triggered, and then everyone has to log in, and it will make the things more complex and time consuming. And Jenkins is able to automate all these stages. Okay, so they don't need to know the Jenkins, they are only need to know the Maven. Okay, how to project and organize their code in Maven. Once they are done, they are going to provide you the goals, and you are the one who has to automate it using Jenkins. Okay, now the address book.var has been generated, and let's go to our Jenkins back. Okay, and we are going to create a pipeline for all these, not exactly commands. So this is the code, okay, that we are compiling. So if you go into the Maven from the developer's perspective, the Maven works around achieving the goals. You have to create different goals, and then you have to organize your code in such a way to achieve those goals. That way, the Maven can execute the multiple goals in a serialized way so that your overall execution gets completed. This is how Maven works. Okay, so that is what we are doing here. So you don't need to know about that application thing, just that how you are going to organize everything in the Jenkins. So if you will see, we are having the 5 jobs now. Okay, what do you want to understand? Like how we are compiling this? I can show you the source code if you want. You can go and have a look at the source code. Maven is the entire programming. Okay. Here is the entire code for the Maven. You can go and have a look. Okay. You can start from top pom.xml. In the pom.xml, we have it's all the dependencies have been described. Okay, like what all dependencies this project is having. So Maven is going to resolve all these dependencies and the further dependencies automatically and going to install it. That's what's downloaded from the Maven Central when we run the build for first time. Then comes your build.xml. Okay, if you go inside this build.xml, you will find all the test cases and everything. Okay, described over here. These are the properties which this build has been doing. Okay, so you will have to execute them. It contains all the specification of the how the build is going to be executed and the different plugins like pmd covertura that we have installed. Okay, now after this, you can go inside the source. Source is the main directory for organizing your source code. Okay, tests are for the test cases that we were running, and source main is every time you will find this folder when you are under the Maven project. Okay, and you can go inside the PMD and so on. All the XML files are there. You can have a look at this code. Okay. Yes, Soham. This is the code only. DevOps is not responsible for the coding part. Okay, this is what belongs to the developer. Okay, and you are automating the code build and deployment. That's a part of the DevOps. Okay, yes, build.xml is written by the developer. Okay, all right. So here we are over the jobs that we have created. Okay, now we are going to create a upstream and a downstream. What this means is that we are going to define in Jenkins that once the first job is completed, then automatically start executing the other job. Okay, how we can do this is the very first time def compile is going to run. Okay, so this is the first trigger that we are going to generate. After def compile, the def code review is going to run. So let's go to def code review. Go to configure. So over here, if you go downwards under the build triggers, you will find trigger build after other projects are built, and here you can specify the project name after the job after which you want to start this triggering of this job. Okay, so you can do def compile. So after def compile, we want this job to be executed. Okay, so what will happen once the def compile gets completed, the Jenkins is going to trigger this build. Okay, automatically. Let's save this. After def code review is executed, okay, we want our QA unit test to run. So we can go to the QA unit test, go to configure, and over here we are going to execute. build after. Okay, here we are going to execute this after dev code review. Okay, save this. This was for the unit test. After this, dev code coverage needs to be executed. So we can go to code coverage and here go to configure. This is going to execute after this is going to execute after QA unit test. Save this. This was for the dev code. This is for the code coverage. And last is the QA package. We are going to generate the artifact. So go to the QA package, configure. So we are going to execute this after code coverage. So here comes code coverage. Okay, let's save this. All right, so this has been done. Now let's go to the plugins and we are going to install the pipeline plugin. Okay, go to manage Jenkins. Inside the manage Jenkins comes your manage plugins. Click on available tab. Inside the available tab, click on let this page load and then we are going to search for the build pipeline plugin. Okay, go to the build build pipeline. Okay, here is the build pipeline plugin. Select it, click on install without restart. So the build pipeline plugin is going to get installed. So this is installing right now. Let's go to the QB package and let's go to cart folder. Now over here we are going to click on this plus sign and it asks for a build pipeline view. So let's select the build pipeline view and
No, Muhammad. मग मला नखाव बरं त्याच्यात.
And inside this we are going to generate a dev build pipeline. Okay, so we are going to create a pipeline view for our jobs to get executed. Click on OK. And over here we are going to select the initial job, which is our def compile. Okay, so the very first job that is going to execute is def compile, and all the subsequent jobs are going to get executed after that. Click on OK. So here is our build pipeline. Okay, and when we execute, all the jobs are going to get serialized, and we can directly see the output on our build pipeline itself. Okay, so let's trigger the build now and see how it executes. Now the build which is triggering will be in green state. Okay, and if something goes wrong, then it will become red and blue are to be executed. Okay, so let's start by executing this build pipeline. So here it is. This has become yellow, so that is, it means it's executed right now. Okay, now if you have to see the logs of this build, you can directly click on the terminal icon, okay, console, and you can directly see the logs getting executed here itself. Now once this is completed, the other build is automatically going to get start. You see, here it is, and you can also see how much time it took for your build to complete one stage. Okay, so here it took around 27 seconds to complete the compilation part. Okay, and then the code review part is running. Okay, so you can click on it and check the output directly. Okay, and you will, once this is completed, automatically the unit tests are going to get executed. We can refresh this. So the QA unit tests are executing now. So this has been executed. Next, the code coverage will automatically start. Okay. Yes, so you can restrict the users. So in the build metrics, you can restrict the user on the project basis as well. Okay. and they will only have the view which they are aligned to see. Okay. And lastly is the QA package. So lastly, the QA package is running and the package is going to be generated. So I showed you the matrix in our last session. Okay. So you can go to manage Jenkins. Okay. And inside the manage Jenkins, you will go to the configure global security. Inside the configure global security, here is the permissions that you can provide to the users. So depending upon the user what they want to do, you can provide them the appropriate permissions. Okay. And I have provided all the permissions because mine is an admin user. Okay. Now another thing is you also have project based metrics. Okay. So project wise you can also select each and every access that you want to give. Okay. That is project based metrics. You can follow that as well. Okay. This is how you are going to provide the access and restrict the user from executing the builds and all. Okay. Whatever permission you are going to define inside the matrix, that is going to be applied to the user. All right, so this has been success and it is completed. So the pipeline has been completed now. Okay. So this is how you can generate the pipelines and the views is there. Okay. So you can execute anything. Anyone having any questions still here? If you select the pipeline, then the pipeline view will come. If you select the jobs, then jobs will come. It's up to you how you want to execute this. Okay. Now, till here, we have created one of the pipeline by manually creating the jobs and then using the plugin we have created the pipeline. Now there is another way of creating the pipeline. Okay. So we can go back to the cart we are here. Okay. Click on new item. Now let me show you one of the code. All right, so here is one of our Jenkins file. Now, all the stages that we have described in our pipeline were created manually. It is possible to automate the stage creation. Okay, So what you can do is you can create a stage automatically in the Jenkins file and commit that Jenkins file along with the developer's repository. Okay. And now point the Jenkins directly over that Jenkins file, so that Jenkins file, once the Jenkins download the source code, it's automatically going to use the Jenkins file to create your job. Okay, this is similar to something like we can create the VMs through Vagrant. Okay, sorry, with the virtual box. Okay, but we can automate the VM creation through Vagrant file. Okay, similarly in the Jenkins you can create a Jenkins file, in which case you don't have to create these jobs manually, and when the Jenkins file run, automatically the stage is going to be created and the build is going to be triggered. Okay. Nupur, you don't need to use the Bitbucket. If you want to use the GitHub, that's also fine. But you will have to use some repository. Okay, not specifically Bitbucket, but at least some repository to host your code. Okay, that the Jenkins is going to compile. So let's have a look at the Jenkins file, how we can use the Jenkins file. Okay, now Jenkins file is having a definite structure. So you are going to start with the pipeline keyword. Okay, then you can specify any agent type that is used for building. Okay, then you will have to define the stages. In stages you can add as many stages as you want. Okay, so define your stage. Okay, and then under the stage you will have to define the steps that you want to execute, and we have directly executed a shell. Okay, commands in the shell. Okay, so javac is a Java compiler which is compiling the Java code and creating a class file which we are loading inside the manifest file, and then we are running that class file, okay, in order to execute our code. Okay, then the next stage comes our where our run file is generating. Now the last jar command will create a jar file, and then that jar file is going to be run, and the output is going to be recorded, and further artifact is being generated with the fingerprint. Okay, these are the different stages for our build. Okay, and if you go through this source code, this is a very basic source code which I've written. This is for getting the area of the rectangle. Okay, it's a very simple program just to get an area of a rectangle. Okay, but this needs to be compiled. So let's see how we can compile this Java code. Okay, so this is our repository, and now always remember that the Jenkins file should be committed inside the root of the code. That is, this is the top level directory, you see. So this should always be inside the top level directory, not inside the further subdirectories. If I put over here, Jenkins will not execute it. It will think it's a part of a repository and going to execute that. Okay. So let's go back to the Jenkins, and here uh, let's create a rectangle app. Okay, and we are going to create a multi-branch configuration project. Okay, click on OK. Now inside this we are going to get to Git, and we are going to provide the repository URL. Okay, we have provided the Jenkins file. and let's just save, apply and save. Click on build now. Okay, seems there is a problem with the Git. Let's create this again. I think there is some issue. Click on new item, say rectangle app. Okay, we are going to select multi-branch pipeline, not the multi-configuration, but multi-branch pipeline. Click on OK. Okay, over here, its mode is by Jenkins file. Okay, so we are just going to add the source here. This is Git, and we are going to provide the repository URL and the user. Let's click on apply, save. So here it is. It has scanning for the branch, but seems this is not having the permission. That's why it's failing. So what we can do is we can go to the Jenkins server, switch to Jenkins user, and take the public key of the Jenkins and copy this public key inside our repository. So we can go to the repository, go to settings, inside the settings, go to access keys, and here we can add the Jenkins. Okay, go to the Jenkins, paste your key, click on add key, and we are going to go to the source code again. Click on clone this repository, copy this, and let's go to the temp directory and try to take a clone of this. Okay, so we are able to take the clone now. So let's go back to the Jenkins, and inside this, let's click on scan multi-branch pipeline now. So the scan has started. Permission denied. Let's go to configure. Click on add. Username is Jenkins and enter the key. Click on add. Apply, save. Okay. So somehow there is a permission issue coming. Go to the settings. Let's make this public. Okay. Let's copy this. And here we can paste. So it has discovered the master branch now. If we go inside this application, okay, it automatically discovers the branch. Since our repository was having the master branch only, so it has automatically taken that branch. And if we go inside the execution of this code, you will see the console output that it has taken a git pull and it has obtained the Jenkins file from the repository. Okay. Now from the Jenkins file, this is going to start the build of, and execute the stages that we have defined in the Jenkins file. Okay, yeah, so yes, developers will have the access to Jenkins file when you are going to put it, but you will have to tell them that this is like they know that this will be used for the build and the deployment, so they are not going to make any changes to that. And if someone is making a change to it, you can track it via the GitHub. Okay, so this is a common practice to be followed for automation. And uh, I don't think that anyone is making these type of changes like that, because all the changes can be triggered, will can be tracked inside the Git. Okay, this is for automation, because once you have created a Jenkins file, you don't need to do the steps manually for creating a job. That gets automated, and you just create the project like this and execute, and it automatically creates everything for you. Okay. So let this run. This is a pipeline is going to be created and executed. So there we go. The Jenkins is executing the master and executing the stage that we have defined. So it compiles the source code. Okay. And it calculates the area. Okay. And there we go. The job has completed. Now, if we go inside this rectangle app, you will see the build pipeline will automatically have been created for this job. So if we go inside this master branch, you see here it is, the build pipeline has been created. Okay, and it shows how much time the each stage took, and you can click on the logs to generate the logs here itself. Here are the logs. Okay, similarly you can just see any of the logs, and you can expand according to your requirement, like what was executed and when it was executed. Okay, so that this is how you can create the pipelines. Okay, so anyone having any questions still here, because this completes our Jenkins lab, and we are going to start with the Kubernetes next. So anyone having any doubt can ask now, else we are going to start with the Kubernetes next. Yeah, you can see that. Okay, so what you can do is, let's say I can show you via direct HCP right now. Okay, later on, you can, if you are writing the Ansible, you can write the Ansible as well. Okay, for deploying. And let's say, let's deploy this on the slave node itself. So what I'm going to do is, on the slave node, we are going to get inside the temp directory, and I will let's create a Tomcat over here and deploy inside that Tomcat service. Okay. So what we can do is, we can go back under the QA package. Okay. And I'm going to just duplicate this. Go to configure. Soham, you can pass. See, if you have to pass any of the variables in your script, then you are going to use the build with parameters. Okay, that's just a way to describe the variables in your build. That's what build with parameters mean. Okay, and another thing that I wanted is, you can go to post build action. Okay, and okay, go to build step and create execute shell. Now inside this execute shell, you can go ahead and whatever variables that you have to define, you are going to put that inside the build with parameters. And then when you run the job, those variables can be taken and executed. That's it, nothing else. And there are pre-built variables in the Jenkins. You can use that as well, that I showed you during this theory part. Okay. Some of the variables like the job number and all are provided by the Jenkins directly. Now, the main thing is that when we are completed executing, then you can directly run the Ansible over here if you want, or you can run the shell scripts like bin bash. Okay. Here I'm going to simply copy the artifact. Okay. So what we can do is like this. The artifact which is generated after the build can be directly copied onto the remote server. So we can say copy this. This is the source artifact generating, and this is the slave server. 192.168, 192.168.23.8. Let's say root at the rate this, okay, colon slash temp slash tomcat, like that, and we can say okay, like this, and then you might want to restart some service also, so you can do systemctl restart tomcat, like that. Okay, I have just written the shell script, but you should use the Ansible. Now you will need to go to your Maven server .ssh id underscore rsa.pub and copy this inside your authorized key file. Save this and try to ssh. Okay, let's try and run this now and see what happens. Okay, so this has been executed. If we go inside the temp, okay, we have a Tomcat directory, and if we go inside the Tomcat, you will see the address book.war file. Now you can do this on any number of servers. Just make them passwordless and run the shell script. That is one of the way. But if you want a better way to be done, that is through the Ansible. You can write the entire deployment in the way that you want to do. Okay, using the Ansible configuration. I hope that's clear to everyone. So I'm just going to start the Kubernetes machines now. Okay, so this will take around 5 minutes. If you want, you can take a 5 minutes break, and when we are back, we are going to start with the Kubernetes. Okay, that is our last topic. Okay, to be completed. So if you want, you can take a 5 minutes break, and when you are back, we are going to start with the Kubernetes. So I'm working on the creation of the Kubernetes machines. All right, so we have started this. Let the three VMs come up and running, and we are going to start with the Kubernetes. So let me just get the keys ready, and then we are going to start. Let's say this is node 1. Let's say the private key. You can say private key, yes. And let's say this is node 2. Let's go to Kubernetes, Kubernetes master, master.pk. Let's change settings. Boot opens, change, increase the text size. All right, so all the three nodes are ready now. Let's start with our with the Kubernetes installation. Okay. All right, so let's start now, and we are going to close this one. Let's first set up the host name. Okay, so we are going to use hostname ctl set hyphen hostname. This is Kubernetes master. Then next comes Kubernetes node 1. So we can do hostname ctl set hyphen hostname. This can be Kubernetes, or this can be node 1. Okay, and finally the third one, this can be your node 2. We can say this as node 2. Run bash. Okay, so all the three of them are ready now. This is your Kubernetes master node, node 2, node 1, and node 2. All right, so we are going to make an entry inside the etc host file. Okay, so let's go to the etc host file and let's make an entry over here. Over here, the IP is 33.7. And then finally it's 33.9. Let's save this. Let's go to the etc host file, make the same entry over here, and same entry over here as well. Okay, so all the three servers, we have made the entry now, and next we are good to start with the installation. Okay, so first of all we will have to disable the SE Linux. So I'm sharing the commands with you. You can use them. Okay, so we are going to do set enforce 0. Okay, all right, so very first thing that you have to do is like disable the SE Linux. Okay, now every time you are doing these steps, just do it on all the three nodes, because same set of steps needs to be executed on all the nodes. Okay, So we have disabled the SE Linux. Next is mod. We have to PR net filter module is used for cluster communication. So we will have to enable that inside the kernel. So we are going to do mod prop PR underscore net filter. Okay. This is required for the cluster communication in Linux. So you will have to enable this. All right. So after enabling the mod prop filter, you will have to call on the IP tables. Okay. So just echo this one value of one inside the kernel settings. Okay. So the command I have shared with you in the chat window, just echo the one to all the servers inside the IP, call IP tables. All right. So now we are going to install the dependencies. So you just do yum install hyphen y yum hyphen utils and then device hyphen mapper hyphen persistent hyphen data and lvm2. Okay, so these are the dependencies for the yum that we have to install. Press enter. Similarly, for all the nodes we are going to install these dependencies. Okay. So let the dependencies install and then we are going to continue. All right, so dependencies have been installed now. Next, we are going to install the Docker. So we are going to do wget get.docker.com. This downloads the script from Docker website. Okay, so let's download this on all the nodes and let's execute this shell script, which is going to install all the requirements for the Docker automatically. Sorry. So it's going to install the Docker. Docker is required for running the Docker containers over the Kubernetes. So let's install the Docker. Wait for the Docker installation to complete. So the Docker is going to install now. It will take a couple of minutes. So let's wait for the Docker to install. This is taking some time. Installation. So, all right. So this is completed now. So Docker is completed. Okay. Now, once the Docker has been installed, go ahead and install the Kubernetes. First of all, you will have to include the Kubernetes repository, yum repository. I am sharing you the commands here. For the dependencies, Sujit, I am sharing you the command. For dependencies, use the yum command, this one. Okay. Okay, this is where we are including the Kubernetes repository. Okay, run this. This basically creates the Kubernetes.repo file, which is being used by the yum. Okay, so what you can do is now you can do yum install, run it on all the three nodes, and then go back and do yum install -y. You need to install the kubelet, kube adm, and kubectl command. Okay, so just copy this and install on all the three nodes. Okay, Here is the command for installing all the three. And then we are going to change the C group driver if it's not already changed. Okay. The Kube ADM is the Kubernetes administrative tools which has all the command lines for managing the Kubernetes cluster. Okay. So this has been installed now. Okay. Now we are going to initialize the Kubernetes. So before initializing, we will have to start the Docker. So we can do systemctl start Docker. Once the Docker has been started, enable the Docker service. And then finally check the status. So Docker is up and running. Okay. Now let's initialize the Kube ADM. We can do Kube ADM init. One minute. Okay. Let's do Kube ADM init. Okay. Hyphen API server hyphen advertise hyphen address. Okay. This we are giving because we are having two IPs over eth0 and eth1. We want the eth1 IP. That's why we are saying to provide use the IP address of 192.168.33.4. Okay, and then hyphen pod network CIDR. CIDR is basically your network range. So we are going to use to 10.244.0.0/16. It is going to provide us with 65,536 IP address to run. Okay, so let's initialize this Kubernetes cluster. This needs to be run only on the Kubernetes master. Don't run this on Kubernetes node 1 or node 2. Okay. This is for creating the Kubernetes master. Let's do system ctl enable kubelet. Okay. Okay, one more thing that you need to do is you need to turn off the swap. So we are going to do swap of -a, sorry, swap of -a, okay, and then we are going to go into the etc fs tab and going to remove the swap mount. Okay, save this. Kubernetes doesn't support the swap, so you will have to turn off the swap and remove it from the fs tab. Otherwise, it's going to restart when the server is going to restart. Okay. So swap will be enabled back. So go to the etc fs tab and remove the swap mount. Okay. Now after this, go and run again kubeadm command. Okay. So now what kubeadm is going to do is it's going to pull the images from the Docker Hub onto the server for installing the Kubernetes. Okay. This will take some time because all the images are being pulled to the Kubernetes master to run the Kubernetes master server. Okay. CIDR is basically classless inter-domain resolution. This is a network related term where you are specifying what is the range of IP address that you are having. Okay. So starting from the 10.244 up to 65,536 IP address you can have. This is what /16 means. And you can have 2 raised to power /16. This is how you compute how many IP address you are having. Okay. This is from the networking background. So this is how we are initiating the CIDR range. Okay. All right, so Kubernetes installation has been completed now, and we need this token. Okay, and let's copy this to a file. So what we can do is now let's copy this entire file. Okay, and let's switch to the vagrant user. Okay, when we are in the vagrant user, just let's execute the following commands. So what this does is it copies the admin configuration for the Kubernetes into the user home directory, so that that user is able to run and manage the Kubernetes instead of the root user. Okay, so that the containers are not having all the permissions, but rather it's being run through the user. Now the token which we get from the Kubernetes, this is required to add the any of the node to the running cluster. Okay, so what now since the Kubernetes has been installed, so we can check out the nodes which are running. Okay, so I can show you using kubectl get nodes. Okay, you can see all the nodes in this cluster right now. So you will see only the Kubernetes master node is there. Okay, rest of the nodes are not there. Okay, let's clear this. So right now our cluster is having just one node, that is Kubernetes master, and that will take some time to become ready. Okay, so what we can do is if we want to add another node into the cluster, we will have to use this kubeadm command, and all the steps should be done on that other node as well, except the initializing of the Kubernetes cluster. Okay, now we can go to our node 1 and run this kubeadm command. Okay, now once we run this, it's going to activate the kubelet, and that kubelet is going to connect with the kube API server, and once the communication has been established with the Kubernetes cluster, this node will be enrolled as the Kubernetes node for running the Docker containers. Okay, now once since this has been done, we can go back and run the kubectl get node command. So you will see node 1 is there now. Okay, and now we can similarly go to the another node and run the same command over there as well. Okay, so this one node 2 is also going to join the Kubernetes configuration. Okay, all right, so we can go back now to Kubernetes get node. Okay, now after this has been done, okay, let's let's apply the pod network. Okay, so we are going to use the flannel networking in the Kubernetes. Okay, so I'm going to share the command with you. Just run this command to apply the flannel networking in the Kubernetes. Okay, this is going to apply the flannel networking. Okay, so this has been created, the flannel networking has been created now. And if we do kubectl get nodes, let's do kubectl describe node 1. So the kube proxy is starting. That's why it's showing node not ready. Let's see kubectl get nodes. And all the three nodes are ready now. Okay. So our Kubernetes cluster is up and running. Okay. Now let's see how we can create a deployment in the Kubernetes. Okay. So let's create a deployment in the Kubernetes. See, deployment is run to run the containers. So let's do a deployment of Nginx. So what we are going to do, kubectl create deployment Nginx, and we are going to provide the image name. Okay, that is Nginx. So Kubernetes is an orchestration tool. Before running the container in the Kubernetes, you would already have performed all the steps like building your images and all. The Kubernetes is there to run your containers. Okay, once you have the image and everything ready, you can create the deployment using this command and provide the image name. Now this image can be called from your private repository. I already covered this when we covered the Docker session. So you can call the images from your private repository as registry as well. Okay. So let's create this Nginx deployment. So it says that the Nginx deployment has been created. Now we can use the kubectl command and get the pods because all the containers are run inside the pods. So we can run kubectl get pods. It says that the Nginx container is creating. That's because the container image will be downloaded. Then Kube API server is going to call the kubelet, and kubelet is going to spawn a new pod, and inside that pod, that container is going to run. Okay, this all will be done very smoothly if this should come up and running within a matter of few seconds. Okay, depending upon your network speed and your availability of the resources, this should come up and running in a short while. So it says it's running now. Okay, let's say after running the initial application, you want to scale the application. Okay, so you can scale your deployment. You can use kubectl scale deployment nginx. Okay, we are scaling the nginx deployment and define the number of replicas you want. Right now only one is there. By default it's one. You can set as many as pods as you want to run. Let's say we want to run 4 pods. Okay, now if we do kubectl get pods, you will see there are 4 pods, okay, of nginx. So you see the scaling of the pods become very easy when you are running the Kubernetes. Okay, next is uh, let's take a practical problem. Okay, now since you are working as a DevOps engineer, okay, then you will have to deploy the Java application. Okay, so there will be scenarios where you will have to create the multiple environment, because then let's consider a case. Let's say the QA team and the development team both are working simultaneously. Now QA folks wants that they should have an environment where they can perform their final testing, but at the same time they don't want to lock the environment and want that the development team should continue developing and creating the new features in their application. So you will have to create 2 different environments within the Kubernetes. One is your test environment, and for developers you will have to create the dev environment. The dev environment, developers are going to continue working without worrying about the test environment, and test environment is going to run the code with which the developers have finished developing, and it's ready to be tested, so the QA folks can test it out. Now both the environments should be logically separated, so that each of the environments pods are not directly calling to each other. So you will have to install the Apache web server, Tomcat server, and MongoDB to run your application. Okay, so this is the problem that we are going to solve now. Okay, so this can be solved using the namespace. If you remember, namespace is a logical separation between the different environments in the same cluster. So it's like that we are running in the same cluster. That is, we are running in the same Kubernetes cluster, but we are going to create a logically separate environment. Okay, so this, let's use kubectl create namespace. Okay, we can create 2 namespaces, that is dev, and then another one is test. Okay, this can act as our environment. And now since we are having 3 deployments, that is, we have to run Apache web server, Tomcat server, and MongoDB. So we can create a deployment for them. We can do kubectl create deployment httpd-dev. Okay, this is for the dev server, Apache. Okay, and image of the Apache web server that we are going to use. So let's call the httpd image. Then the namespace in which we want to create this container, that is dev. Okay, -n is for namespace. Do this deployment and it will create an Apache web server. Similarly, we can do for the Tomcat. Specify the image that you want to use Tomcat in the dev environment. And finally, we want to use the Mongo as well. In the dev. Okay, so Mongo has been created. Now all the 3 applications have been created after the image has been created, and then what we can do is we can test, get the pods. So we can do kubectl get pods. Now we only want the pods of dev environment, so we can do -n dev. Okay, so it will show only the pods of dev environment. Okay, so there are the 3 pods for the dev environment. Similarly, we can do for the test as well, httpd test, and we can specify the namespace as test. there will be a space over here. Okay, now similarly we can do for the tomcat, and similarly we can do for the mongo as well. So now we can get pods kubectl get, we can do kubectl get pods hyphen n test. Okay, so it will get all the pods running in the test environment. Okay, now what if I don't know all the namespaces? I want to get all the namespaces. See, if you don't specify the namespaces, then Kubernetes creates a default namespace for you in which it runs your containers. At the same time, Kubernetes also runs the various services in the containers, and that it deploys in the kube system. Okay, that's also kube system is also a namespace. Okay, so you can list all the namespace using kubectl get pods hyphen hyphen all hyphen namespaces, and it is going to show you all the namespaces that exist. So there is a default namespace, dev namespace, kube system namespace, test namespace. Okay, and you can, this is how you are going to organize and call the pods. Okay, now let's see how we can assign the labels or tags to our pods. So we can do, let's do kubectl get pods. So we are having in this nginx running. Let's take this nginx and we can do kubectl label pod name. Okay, and whatever tag that you want to put. Let's say we want to put it version equal to v1. Okay, so that label is going to be assigned to this pod. Now we can check for the labels using kubectl get pod name. Okay, and hyphen hyphen show hyphen labels. Okay, this is going to show all the labels assigned to this pod. So here are all the labels that has been assigned to this pod. So here is the version. Okay, so you can see the version for the pod as well. Okay, this is how you can assign the labels to your pods for easy categorization. Okay, now let's see how we can create a deployment from a configuration file. Okay, so what we can do is we can create a nginx hyphen deployment. This is what you are going to write when you are deploying the files in the nginx, because you are not going to run the ad hoc commands. So let me share this configuration with you. Yeah, so I'm showing you how you can define the ports and all. Okay, so this is the configuration. Let me just share it. Okay, here it starts from the API version. You can keep incrementing the API version every time you are doing a deployment. Okay, to track the different versions of your pods. Then it's a kind of deployment that you are doing. Then you have to provide the name of your container, labels that you want to assign to your container, how many replicas you want to run. Then you can provide the selectors, that is on which pods you are going to apply this configuration. So you can select the selectors and match the labels that you have initially assigned to your pods. So only this configuration is going to be applied to the pods which are having these labels. Okay, this is just similar to what we do in tags in AWS. On basis of tags we are targeting our pods. Okay, so we are targeting app equal to nginx, that is we are only targeting the nginx pods, and we are saying that apply the specification should be nginx 1.7.9 image should run, and we have defined the container port to be running on port 80. Okay, this is the entire configuration for deploying the nginx. Okay, now you can save this. Okay, now after saving you can create a deployment with kubectl create -f nginx deployment .yaml. Okay, now once you do this, it's okay yaml. Okay, let's run this. So deployment has been created. So this is how you can run your deployments. Okay, anyone having any questions still here, because this is how you are going to run the Kubernetes, and that concludes our Kubernetes as well. Okay, so this is how you are going to run the applications in the production environment. All this configuration you can put it inside the Git and do run the Kubernetes like this. Okay, anyone having any questions still here, because this concludes our session and the Kubernetes has completed now. Initialize means that it has created the namespace and doing the deployment inside the namespace. Okay, you can get the pods in the namespaces as I discussed, as we have shown you. Okay, that's like a logical separation, because there will be many more containers running inside your Kubernetes. It's possible to run 500 to thousands of containers, so you need some logical grouping so that you can call the containers on the basis of environments or your application name. Okay, otherwise you will have to list down thousands of containers and it will be very difficult for you to get the actual containers which you want, the status of those containers. Anyone else having any question? Because this concludes our session. Okay, and okay, so Soham, whenever you are doing the deployment, see, Jenkins can connect to the node, okay, over the Kubernetes nodes, and through Jenkins you can execute these commands for the deployments. Okay, so whatever deployment commands we are executing manually, you can directly execute from the Jenkins itself. You can create the Jenkins job and execute the commands from there. That's how you can execute from the Jenkins as well. See, we already showed in the initial, when we started the Jenkins, I showed you how you can execute the shell commands. Now there are large number of plugins also available which you can use in the Jenkins, and you can directly issue the commands as well. So it's up to you how you want to do the all the initial things that we done manually for setting up the Kubernetes. You can automate that through the Ansible, and then you can also run the Ansible from the Jenkins and create a variable where you are passing the server IP address, so that whenever you are going to scale a new server, you can just pass the IP address to it and Jenkins job will run and initiate all those commands that we run manually initially. You remember when we enrolled the Docker container Yum repository, Kubernetes repository, install kubeadm, kubectl. All those commands can be automated into the configuration management, so that as soon as the new nodes comes up, it gets executed. Kubernetes is ready to be installed, then the token which I provided, you can run that. It is going to attach that node inside the Kubernetes, and then you can run the deployment commands in the Jenkins, and it can initiate the deployments, connect to your registry, and set up your containers running in your Kubernetes. Okay. Yes, so when you do this, the Kubernetes is going to create the new servers, automatically switch your code to the newer servers, and revert back to the previous one will be upgraded to the newer versions. That's why I said to you, you should change the version every time you are doing a deployment in the Kubernetes. Guys, there are exercise files also available. Okay, if you want, you can go to your LMS portal. We have the exercises covered for you with the solution, and if you still face any issue, you can reach out to me. Okay. For the performance, you can I initially shared the commands where you can get all the information about the containers and all, how much memory, RAM, CPU is available, like that. So that can be done. Okay. All right, anyone else having any other questions? Yes, Soham, tell me. So what happens in the Kubernetes is, like, there are different monitoring tools which are available. Okay. First of all, whenever we talk about the Kubernetes or any of the automation tool that we are talking, okay, usually the dashboards are not used because all the builds deployments are automated. Okay. If you are using if you are using some GUI, then you will have to go to that GUI and trigger some build or deployment. Okay, that's a manual step. Normally, all these build pipelines and container deployments, all of the part is automated to achieve the continuous integration and continuous deployment. Okay, that's a CI/CD approach. That's why we there are no specific dashboards like that available, but there are third party integration which you can do, and there are large number of monitoring. Like, if we talk about Datadog, it can integrate with the easily with the Kubernetes. An agent of Datadog is going to run, fetch all the matrices of the Kubernetes, and going to publish that into a time series database where you can plot the graphs, and you can look the overall performance of your Kubernetes cluster. Similarly goes with the app dynamics and New Relic. They can monitor your containers. Okay, what's happening inside that, what's the logging, then you can ship the logs in the front end of the containers to the ELK cluster. So it's a complete suite of applications that you will have to build inside your enterprise environment, most of them are paid solutions. Okay, but you have the Grafana, then there is a large number of tools are open source as well. Okay, but that is specifically to the monitoring part which you are referring from the dashboard. Okay, so that's something which is secondary, because the automation is always in the text format. Okay. Tulsiram, we have covered all the topics for you. Okay, and all the labs. Okay, so you can view them inside. Recordings are available in your LMS portal. Okay. Anyone having any other queries? See, I will suggest you to practice more on this. If you are having any issues later as well, you can send out a mail to the support team and they are going to redirect it to me. I will be answering all your queries, okay, whatever you are having. Even if like anything which is remaining, you can reach out to me anytime through Cognitia support. Okay. All right. Thanks everyone for attending the DevOps session. It was great having the session with you all. So, okay, let me just check. You want to see a complete automation. Okay. So let's do one thing. Just give me a second. Let me show you one project. All right, so here is a development project on Kubernetes. Okay, this is related to an application environment. Okay, where we have the entire application being deployed in the various languages like your Golang, PHP, Java, Spark. Okay, this is basically a microservices kind of environment for an e-commerce company. Okay, having cart, catalog, everything deployed. So we can automate this entire deployment of the entire configuration in the Kubernetes. Okay, let me show you. So what I can do is I can go on my node. Okay, inside the Kubernetes, let's create a e-commerce folder. Let's go inside that e-commerce folder, and I'm going to clone my repository. Let's clone this repository. Okay, see, this is a full end project written in the Kubernetes. I'm just showing you when you complete a Kubernetes project how it will look like. Okay. All right, so I have made that. Let me click the save repository. All right, so Git has been installed now. Let's clone our repository. Click yes. Okay, so we can do cat home directory dot ssh id underscore rsa. So we can do ssh keygen hyphen trsa. Let's take this and add the key over here. And let's take a clone now. Okay, so it's downloading all the object files, entire project. All right, so that is being done. Let me show you. Now, if you go inside this and look over here, these are all the deployment file that was created. Okay, so we can do cat cart deployment.yaml. Here is the complete deployment of the service. Okay, now what you can do is we can create a deployment for the entire application now. So let's create a namespace. Let's say kubectl create namespace, and we can say eShop. Okay, so a namespace of eShop has been created, and we can do kubectl -n eShop, that is the namespace. Okay, create -f and the complete configuration file. Okay, let's run this. So it's going to automatically create all the services. Okay, starting from cart, catalog, dispatch, RabbitMQ, ratings, Redis. Okay, you see how easy it is to create the entire application. And now what I can do is I can do kubectl get pods -n eShop. Okay, so you will see that all the containers have been created for my application. These are various microservices we are referring in a production environment. Okay, and after that you will see. Now let this become up and running. So the Linux and the scripting, okay, see, these are the things required for the automation. It's good to have, but over a period of time, when you start working in the DevOps, you will see that this is not now the actively, it's not that you are too much working on it, but sometimes you will face the requirement where you need to have some understanding of the Linux and scripting. So better is you work on those things side by side and follow the curriculum that we have taught to you. Those are more than sufficient to get you a good DevOps working job. Okay. And once you start working and gaining the experience, you will become more and more familiar with the DevOps. So this is getting created. It will take some time for the containers to become up and running. So this is going to take some time for the images to come up. If we do Docker images, So you see it has downloaded all these images onto the system, and more images will be downloaded. So this is going to take some time for the application to come up and running. Once the application is up and running, you can view that in the browser itself. Okay. So, mostly the build and release part should be strong. Okay, then you should have a configuration management tool knowledge and some monitoring knowledge and your containers and the orchestration part. Okay, these are the major things which is being expected from the DevOps by the DevOps interviewer. And once you have done that, they are this is the major questions that you can expect them to ask you. Okay, so here it is, the cart is running now and dispatch service is running now. Similarly, the other services will also be running. Okay, so this is how you can create a web application entirely within the Kubernetes. And you see how much time it took for me to bring the entire environment up and running. If this would we would have done through some configuration management tool or by initial means, this would have taken very much longer time for creating all these services, writing the builds, deployments, running the configuration and all this. But we were having a application already packaged inside the container, and once we run it, entire application comes up and running like that. Okay, though that's the major advantage of running the containers. So three services are up. So all of the services are going to be up and running shortly. Okay, those who want to see can stay back. I will show you within the 5-10 minutes everything should be up and running. But this is the course gets completes here. Okay, and whenever you have written all these configuration in the Kubernetes and you run like this, your entire application can up and running. And you can create easily different environments by passing the different configs within the Kubernetes and run this anywhere. See, this setup can be run anywhere within the cloud, whether on premise, whether on your laptop. Okay, so you can run it anywhere that you like. Okay, all right, so this concludes our training. Okay, you can practice this out running on your laptop. Okay, and everything should come up and running. And then you can visit the browser and over the port 30080 when all the pods are in running status, and that should load your website as well. Okay, all right, thanks everyone. This completes our training. Okay, so I'm going to end the training now. Okay, and go ahead and practice. If you need any other help, send out a mail to the Cognizera support team. They are going to redirect it to me. Okay, all right, thanks everyone. Ending the training now.